So a 3 kilogram electric car is powered by a 12-volt battery if 8.2 amps flows through the circuit to operate the motor at constant power, and the car accelerates from rest, then how fast will the car be moving after 3 seconds? So this is like a Tesla, right? Let's try that. So we got the Cybertruck here. All right, so the first thing that we need to do is list what we know. So we know a couple of things. We know the mass. They give us the mass. Oops. So the mass is equal to 3 kilograms. So it's a tiny car. It's not really a Tesla. We know that the voltage is equal to 12 volts. We know that the current is equal to 8.2 amps. And we want to know how fast it will be going with the final velocity. So this is a conservation of energy problem, because we can figure out the power, which will give us the number of joules per second, and then convert it. So it's similar to the other problem we did. So remember that power is equal to the current times the voltage, or the power in watts is equal to 12. Oops, I wrote it down backwards. I guess it doesn't matter, but 8.2 amps times 12 volts. So then the power is equal to, if you do the math on that, that's 98.4 watts, which is actually 98.4 joules per second. And that'll be helpful. Go ahead. That'll be helpful because we're going to solve for meters, and then it'll end up being per second. So the power then, for every second, the electric motor can generate 9.84 joules. So then we also have to remember that the kinetic energy, so that's joules per second. So there's a little trick we could do here. It tells us it's going to be moving for 3 seconds. So in other words, if we wanted to figure out the power of the car, we just take this 9 in those 3 seconds. So it would be 9.84 joules per second, and then multiply it by 3 seconds. And what that does is that is energy, but it's also the amount of work that gets done, right? So we could say that the work ends up becoming 9. Oh wait, let me back up. If you do that on a calculator, it's 295 joules roughly. So that is the amount of work, but it should also be equal to the kinetic energy. So remember that our 295 joules will be equal to 1/2 times the mass times the velocity squared, remembering that we don't know what the velocity squared is. So then what I need to do is plug in the mass, which is just 3. But first, before I do that, I'm going to multiply both sides by 2. And I should get 590. 590 joules is equal to the mass, which is 3, times the velocity squared, divide both sides by 3. 590 divided by 3. Hold on, I'll just do it. I've got 590. It was 590, right?
Yes.
Okay. Divided by 3. 196.66 is equal to the velocity squared. Take the square root of both sides. So I'm going to take the square root of this bad boy. I get about 4. Wait. Why is it? I did it weird. Okay. Let me go back. Let me clear this out. 196.66666. I'm going to take the square root of that. There it is. 14. It's about 14 meters per second.